let's now look at the binomial theorem. So the binomial theorem, we said it's the second method. The first that we looked at was the Pascal. And if you remember, I said that the main difference is how you get the coefficients. Okay, so how are we getting the coefficients different here? The coefficients for the binomial theorem, you get them through this formula here. Now, the most important things here to note is that we've got three things here. We've got this, the sigma notation, okay? We've got the sigma notation here. We've got this combinations formula, and then we've got the powers, okay? This is what makes up each term, if you remember. So there are three things. There's summation, telling us that we're going to add the terms. There's combination that will help us to get the coefficients. And then there's this one here where we're going to indicate our powers. So what does this come to? It comes down to this formula now. Okay, we're saying summation. You'll see that there's different terms. The first term, second term, and so on and so forth up until we get to the last term, right? So these are the terms, okay? But now we can see that we've got combination here. We've got a combination there. We've got a combination here. This is what helps us to get the default number for the coefficient. And then we can see that the powers with the terms, it's the same as we did with Pascal. The first term, that is from here, the first term reduces, so it's n minus 1 up until it gets to 0. The second term increases, it's 0, 1 till it gets to n. Another important thing to notice here is that this is our counter, okay? This is our counter from 0 to n, so k is our counter. So wherever there is k, that counter will apply. So for example, if I say I'm dealing with the first term, which is going to be 0, right? In order for me to get that term, I'll put 0 here, depending on the power that's here. If it's, say, power 5, for example, if I'm expanding to 5, then the term 0 will have 5 here, n5. This will have 0, okay? Here, we're going to have 5 minus 0, and then here we're going to have 0. So you see that A will have power 5, B will have power 0, and then we'll have a combination which is n0. n0 is 1, okay? So once we understand that, then we are on our way to understanding binomial theorem. So the only complicated thing about binomial theorem is understanding how to expand the notation, this combination notation. Okay, so this combination means that to change it to number, this is not a number, this is not algebraic. Okay, it's just almost like an expression or a notation, sort of. Okay, so to change it to a number, you have to do that. Okay, you have to do this. Remember there's k here, and then you have to do n minus k, like that. So what is this? This is factorial, okay? That is factorial, that is factorial, that is factorial. This whole thing is called a combination, okay? So now let's do a few examples here, up to 5, okay? Let's do a few examples up to 5. So if you have, for example, I'm dealing with, let's say, a plus b power 5. So let's try to get the coefficients. We remember that the coefficients were 1, 5. It was 1, 5, 10, 10, 1, 5. Okay. So we say that if we set power 5, we'll get 1, 5, 10, 10, 5, and 1. Like that. So let's get this and see how we use the combinations formula. So the first one will be 5, 0. Okay. So 5, 0, we said we're going to use this. It's going to be 5 factorial over k will be 0. Okay. And then in brackets here, we'll have 5 minus 0 factorial. Okay, so what does this give us? It gives us 5 factorial over, this is 0, this is 1. This is a special one that you have to know. Okay, 0 factorial is not 0, it's 1. Okay, it's 1. So here we're going to have 1. Okay, 1 times 5 factorial, we have 5 factorial, so it's 1. So we see that the first term will be 1. Okay, let's check the second term. The second term, we see here that it will be 5. But since we're powering to 5, again we say 5, and then we're dealing with the second term, which is 1. Right? Because the first term it starts from 0. Remember we said we've got 6 terms here. So it will be 0, 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5, 6 terms. Right? So the second term will have 1 here, not 2. So this one will be 5 factorial, n factorial. So this is something that you have to know. Okay? And then we have 1 factorial, right? And then here we're going to have 4 factorial. Why 4 factorial? It's because we're doing 5 minus 1, which is 4. Now, how do you reduce, how do you change this factorial into a number? So a factorial, if I had, let's say 5 factorial, it means that I'm multiplying 5 times 4 times 3 times 2 times 1 up to 1. You don't get to 0. Okay, 5 factorial means it's 5. You start from the number itself going all the way down to 1. So you multiply these. So this is actually 5 times 4 factorial. Okay, this 1 factorial is 1. Okay, we're not multiplying anything, so it's 1. Then this one is going to be 4 factorial. We maintain our 4 factorial there. I could have done 4 times 3 times 2 times 1. Here I continue and I continue. Still, I'll cancel those. So this is a quicker way of getting to your number. So this is 5. You'll see that the second term is 5. Right? So for binomial, my only advice is you get to master how to play around with this. That is the only thing that really messes you up. Okay. Okay, so we're going to look at this term here. Okay, this one here. So now how do we count? Remember we said that this is first term, second term, third term, fourth term, right? But the fourth, remember n here is not 4. It's n minus 1. So it's going to be 3. Okay, so we're going to do 5, 3 factorial. Not 3 factorial. Okay, we'll do 5, 3. That's a combination of 5 and 3. So here we're going to have 5 factorial over 3 factorial. And then here in the brackets, this is very important to note. Here in the brackets, we're going to have 5 minus 3, which is 2 factorial. Right. You're not adding these so that you get 1. That's not what we're doing. So we're going to now expand these fully. Okay. So this is going to be 5, 4, 3, 2, 1. Right? We're going to divide it by what? We're going to divide it by, this one is going to be 3, 2, 1. Then we continue, 2, 1. So we find terms that we can get rid of. And then this, and that gives us 2. So we multiply those 2, we get 10. You'll see why this is 10. But why do we have 2 10s? Why do 10s repeat? It's because this first one will be 5 factorial. And then this side, this time we'll have 2. This time, this side will have 3 factorial. Okay? So once you get this, it's the same as this one. It's just that they're arranged differently. But it doesn't matter when it's multiplication. So this will give you 3 factorial and 2 factorial, like that. So that will also give you a 10. And this is why you have a 10 for the second term. So I cannot emphasize enough. Learn how to do this and you will master binomial theorem, because this is easy. That part is easy. Here it's easy. You know, you're adding everything. This is what gives problems. Okay, so master combinations. Okay, master combinations, and then you'll be on your way, right? You'll be on your way, right? So N, choose KE. That's what how they express it. So all the best as you are going through the binomial. We'll do some examples in our next video.